the most common types of stoves are flame stoves and electric coil stoves. So some pros to a flame stove are you have fast and easy temperature control, and it costs less to operate than an electric stove. And even if there's a blackout, you're still able to use your gas stove because it doesn't actually run on electricity. Another thing is that it cools down faster compared to a electric coil stove, and it also heats up faster. There are, however, some drawbacks, such as trying to get a consistent temperature every single time you turn on the stove, because since there aren't any preset temperatures, you have to try to estimate the same place where you turn the knob every single time. Another thing is that people tend to use the wrong size burner for your specific pot or pan, because if your pan is too big, then you end up having hot spots, and if your pan is too small, then you end up wasting a lot of the energy. A flame stove is also harder to clean, because in order to clean it, you would have to take off your grate and take off the burner head. Then you can clean out all the internals. The final con is that it tends to be harder to install, since you have to hook up gas lines. And moving on to the electric coil stove, here are some pros. Since there's a smooth top to it, it's easier to clean, there's better heat distribution, and it can be used as storage when it's not actually used as a stove. And the stove can actually achieve higher temperatures. It's also easier to install since there are no gas lines and all you have to do is just plug in the device. And moving on to some cons. The obvious one is that if there's a blackout, you can't use it since there's no electricity. And it's pretty easy to shatter the top with a quick change in temperature. And the final con is that it takes a while for the coils to heat up before you can start cooking anything. Now, a newer type of stove called the induction stove. So how it cooks things is rather than using a direct heat source, it actually uses induction to heat up only the pan. And the good thing is that it doesn't actually heat up the pan, as it only heats up the stovetop, so it's very safe around kids. And it's also very efficient with heat energy, and it heats up a lot faster. And just like the electric stove, it has a smooth top, so it's very easy to clean. There are, however, some drawbacks, such as an induction stove being very expensive, and some of the old pans may not actually be compatible, because the only pans that are compatible with the induction stove are cast iron black metal and stainless steel with a magnetic grate base.
Okay, so what is induction? Induction is one of the two conduction, but the unique thing about induction is that your neutral object and your charge object never touch, so there's never a direct transfer of electrons. So first you start off with the neutrally conducting sphere, as shown by the even distribution of positive and negative charges. And then when you take a charged object, and in this case we'll use negative charge, there's going to be an uneven distribution of charges. And since positive and negative are opposites, they attract. So there's going to be a right side, which is primarily positively charged, and the left side, which is primarily negatively charged. And the important thing to note is that you need to ground your neutral conductor to actually charge the object, because grounding is basically connecting your object to the earth, and the earth has a lot more electrons than that object, so it'll suck in more of the electrons. So this is why the electrons on the left side move into the earth, and then this causes the formerly negative neutral sphere to be positive now. And the important thing to note is that if there is no grounding and you just took away the negatively charged rod, then the object would just be neutral again. So once you have this diagram that points out just positively charged sphere and a negatively charged rod, take the rod away, it would just be a positively charged sphere, and that's how induction works. And the important thing to note is that your neutral sphere will end up having the opposite charge as your charged rod.
2, 1.
Okay, so what is an eddy current? Well, the eddy current is the fundamental stepping stone for our induction stove, and it's the power source basically of how those stoves work. So the word eddy and eddy current means circular current, and when a conductor is kept interchanging with magnetic field, the currents are induced in the body of the conductor. So these currents can increase the temperature due to the increase in internal energy, which is caused by the vibration of molecules within the conductor. And these currents also resist the movement of a magnetic field induced on the conductor, which is shown by these diagrams right here. So there's a coil that's connected to a voltmeter, and that results in various different magnitudes of magnetic fields. And for example, this is a small one, this is a bigger one. So these magnetic fields are not constant. It induces a current within the conducting metal that's below it, and these result in eddy currents, which are represented by these purple lines drawn in circles.
One.
So this is how an induction stove works. Typically what you'll have in the setup and what is sold today is you'll have a ceramic plate, which is typically like you would have on a stove, and under the ceramic plate is a metal coil. So what happens is the electric source that's connected to this coil will go through and create an electrical current. And when this electrical current goes through the coil, what will happen is you'll have a small magnetic field. The magnetic field is not that strong and won't like interfere with anything, but what happens is it is just strong enough to go past the ceramic plate and reach the pot. So once it reaches the pot, what actually happens is we have an electrical current that's created within the pot. So with this electrical current in the pot, we have an energy source that is being created. And a lot of the heat that is created within this pot actually stays within it because the pot is typically made of iron where it's a weak conductor, and a lot of the energy that's created from this electrical current stays within it. And to compare this to a gas stove, for example, what you have is your stove, which releases a heat source. And what happens is the heat source is very strong right next to the stove where it's released.
What the? What are you guys?
Most of the pot. But the problem is, as it goes farther and farther out, you have a weaker. The spread of the energy around this pot is not the proper.
Hello?
Mute yourself. So you have hot spots in areas, and it might not be the best way for cooking. Compared to if you use an induction stove, what actually happens is your ceramic plate doesn't get hot at all because the energy source isn't created between the ceramic plate and the pot, but actually the magnetic field in the pot. So all the energy and the heat is created within the pot itself. So what you'll have is a very uniform, fast way of heating up a pot that is actually way better for cooking.
After saying all this, what exactly is the point of induction? How would we incorporate it in our daily life? Well, first off, you may not expect this, but we actually use induction very often in our everyday lives. You can expect to see induction in many items such as speakers, laboratories, welders, chargers for like mobile phones, generators, radios, microphones, lighting, induction stoves for induction cooking, and like ignition in petrol engines and cars. In a speaker, the electromagnet and thin membrane react to change in current, and the speaker's magnetic field interacts with the field of the permanent magnet. Induction cooking, as was previously mentioned, the cooking vessel is heated by magnetic induction instead of thermal conduction from flame. An alternating electric current results in oscillating magnetic field that induces a magnetic flux and repeatedly magnetizes the pot. This results in production of large eddy currents in the pot, and the resistance of the pot heats it. Induction has been slowly taking over items in our lives since it's much more convenient. You might have seen an induction wireless charger when you are in Starbucks or any of those other cafes that provide wireless charging. The use of electromagnetic generators is also part of induction. Electricity generators go into the production of roadway vehicles, bicycles, sailboats, genset, human-powered electrical generators, and even bullet trains. In bullet trains, magnetic levitation is supported by the use of powerful electromagnets, allowing the train to float on a magnetic cushion and ride around at a high speed of 500 kilometers per hour without even touching the track. These are all examples of how induction is used in our daily lives.